this video, we'll talk through the National 5 Chemistry Unit 1 topic of atomic structure. By the end of this video, you should be able to describe how the periodic table is arranged, name and give properties of the subatomic particles, use Euclid notation to identify the numbers of the subatomic particles, and define and identify isotopes. During this topic, and pretty much all of the course, the SQA data booklet is going to come in very handy. You will be given a data booklet. Use it. If you're told in the question you may wish to use the data booklet, that means use the data booklet. Starting off with the periodic table, every element has its own symbol and its own atomic number. The first letter of a symbol is always a capital letter, and the second one will be the lowercase. And in this case, for calcium, the first one's correct. You have a data booklet to refer to, so make sure you're looking at it carefully to get the exact correct symbol for a particular element. You might be asked about going across the way in the periodic table, so the rows are called periods, and then our up and down columns are called groups. One of the first classifications we can do is that metals are found on the left-hand side of the periodic table, and non-metals found on the right-hand side of the periodic table. The data booklet has information about that as well. There's three groups you need to know about in the periodic table. Those are group 1, 7, and then H/0, and those are the alkali metals, halogens, and noble gases. Our alkali metals are metals, which are reactive. We have our noble gases, which are non-metals, which are unreactive. We also need to know about the elements in between group 2 and group 3, which are called transition metals, and again, the data booklet tells us this. Moving on to types of questions that you can be asked. First type of question is they could give you a list and ask you to identify, in this case, which of these is an element. And an element, the name will match exactly what's in the periodic table. So when we have a scan through the pages with the full periodic table, you will see that fluorine is found written exactly the same. Therefore, fluorine is our element from this list. The second type of question they can ask you is involving the groups. And in this case, it's saying that fluorine is found in group 7 of the periodic table, and you have to name the family of elements to which it belongs. There are three families that we could be asked about. We have our group 1, alkali metals, group 7, the halogens, and group H/0 being our noble gases. It's telling us that it's in group 7, therefore we have a member of the halogens. A third type of question, they can give you some of the properties of an element and ask you to decide what group it belongs to. Here we've got an element Z, which is a gas. It's not made up of molecules, and it does not react with other elements. The most important part of this is the last piece of information they tell us, which is that it does not react with other elements. If it does not react with elements, it's likely to be a noble gas, and a noble gas is group 8/0, giving us our answer of D. Moving on to our subatomic particles, these are the three smaller particles that are found within atoms, and those are protons, neutrons, and electrons. We have our protons and neutrons found within the nucleus, and the electrons are found in orbits outside of the nucleus. Our protons and neutrons have a mass of 1 compared to a mass of 0 for electrons, and then a proton is positively charged, P proton, positive. We have our neutrons, which have no charge, and our electrons are negatively charged. You'll sometimes see it represented in a little diagram like this, where we've got, again, our protons and neutrons in the middle, and they are surrounded by orbiting electrons. Okay, what kind of questions could we be asked? We could be asked to identify the description of a particular subatomic particle. Here, we're looking at our proton. For me personally, I first look at the charges. The proton has a positive charge. They are also in the nucleus, and that means that we have our answer of C, because it's the only one that matches up. We're going to look at how the electrons are arranged in an atom. We have to know that the first energy level can hold a maximum of 2 electrons. Our second energy level can hold a maximum of 8. And the third energy level can hold a maximum of 8. Our data booklet is going to tell us this information. on page 6. So we can just look them up if we're not sure. Another thing that's useful about the electron arrangements is that elements in the same group have the same number of outer electrons. So in their arrangement, they'll have the same last number. If we look at two members of the alkali metals, sodium and potassium, we can see that they both end in 1. And those are in group 1. Elements in the same period, so going across the way, will have the same number of energy levels. So magnesium and chlorine are in the same row, and they both have 3 energy levels, so 3 numbers in their arrangement. What questions could we be asked? Well, one type of question is they'll give you an arrangement and ask you to say which group does the element belong to. We've got an outer number, a last number of 7, which means it's going to be in group 7. From previously, we've talked about the fact that halogens are group 7. So this is for chlorine, and chlorine is a halogen. So that makes our answer A for this question. Another type of question is they can ask you which of the following elements has a similar chemical properties to argon. And that's just a way of saying which of these elements are in the same group as argon. Just a different way of asking the same question. So when we look at argon, we can see that argon is a noble gas. That's group 8. And we've also got krypton, which is in the same group. And that's our answer for that one. Next, we'll move on to talk about a nuclear notation. This is a short, concise way of representing the information about protons, electrons, and neutrons in an atom or in an ion. So our atomic number tells us the number of protons. We can see that in our diagram here. It's also found in our data booklet. So that means that we've got 17 protons in this atom of chlorine. When we have an atom, atoms have the same number of electrons as protons. So we have the same number of positives as we do negative. So if we've got 17 protons in our atom, we have 17 electrons in our atom. Last piece of information we need is the number of neutrons, and we are going to use the mass number. The mass number is the total number of protons and neutrons. So if we've got 32 protons and neutrons, and we know we've got 17 protons because of the atomic number, and if we take those numbers away from each other, then we end up with our neutrons being 18. Types of questions we can be asked. We can be asked about the charges on the different particles. Now, an atom is neutral because this is asking about positives and negatives, and we have got the equal number of positive and negative particles. So what we've got to look at is which particles are positive and which particles are negative. So protons are positive and electrons are negative. And we're looking for the answer that talks about protons and electrons. And that, for this question, would be answer D. We can be asked about atomic number and mass number. So here we've got the fact that it's got 26 protons, and the atomic number is the number of protons. And our mass number is the number of protons plus neutrons. So using the information that we've got above, that means that we've got an atomic number of 26 and a mass number of 56. Another question they can ask you about, again, a specific element, in this case strontium, the best element in the whole of the world. And we are given information about this strontium atom in the form of a Euclid notation. Question wants to know how many neutrons are present in the atom. Focusing on the question part, how many neutrons are present. Now we can use the information that we've got to first of all find out the number of protons, and that is the same as the atomic number, which is at the bottom. Therefore, we're going to have 38 protons and 38 electrons. If you're not sure which number is which, go to the data booklet, go to the big page, or go to page 6, find the chemical in question, and it will tell you, because there's little keys, it will tell you what the atomic number is. We then need to work out our neutrons, and we're using the fact that mass equals protons plus neutrons. Therefore, neutrons will equal the mass number, take away the number of protons. So it's going to be the difference between the two numbers, which gives us 50 neutrons. Moving on to talk about isotopes. Isotopes have the same atomic number, but they have different mass numbers. A different way of saying that is that they've got the same number of protons, but different number of neutrons. So those are two interlinked descriptions of those. So when we look at sticking with strontium, we've got three different versions of it. We have one with a mass of 84, one with a mass of 86, and one with a mass of 88. If we go to write down about the protons, we have the same number because their atomic number is the same. Because these are atoms, they will have the same number of electrons. Now, to get the neutrons, we are taking the mass number and then we're taking away the atomic number. So the difference between the two numbers. And that gives us a different number of neutrons in each of them. So we can describe these three atoms as being isotopes of each other. Questions they can ask you is they can ask you to identify the particles which are isotopes. We're going to remember our definition as the same atomic number, different mass number. So we're going to look for things which have got the same number of protons, but they've got a different number of neutrons. And that gives us A and C. Another question I might ask is just straight up wanting the definition of isotopes. We can use one of the two definitions that we've talked about. We can define them as being atoms with the same atomic number but different mass number, or we can talk about them having the same number of protons but a different number of neutrons. When you look in the data booklet for the different masses, you'll notice that some of them have decimal places, so they're not whole numbers. And the reason for this is that if you've got an element with multiple versions, or isotopes, the relative atomic mass is used. And this is the average mass, taking into account which of the isotopes is most common. If we go back to the strontium example that we talked about previously, the relative atomic mass of strontium is 87.5. And what this means is that whichever of the three versions is closest to the average, that is the most common version. So 87.5 is closest to 88, therefore our strontium 88 is the most common version. The questions you can be asked regarding relative atomic mass is they could give you some examples of isotopes of each other, and they're going to tell you that this sample has an average atomic mass or relative atomic mass of 20.2. What is the mass number of the most common type of atom? Look at the average, 20.2. It's closest to 20. Therefore, neon 20 is going to be the closest. So the mass number that's most common will be 20. Next type of question is they could give you one which is talking about when you've got a situation where you've got equal quantities of both isotopes. So we've got one isotope which is a mass of 35 and the other one has a mass of 37. If you've got equal quantities of both, your average will lie halfway between the two. And halfway between these two numbers will be 36 atomic mass units, or 36. The other type of question they could ask you is they could ask you to use the formula that is used to calculate the relative atomic mass. They'll give you this if they're going to ask you for it, and it's all just about plugging in numbers and making sure we use brackets correctly in our calculator to get the correct answer. So it tells us here that we've got 55% of mass 79 and 45% of mass 81. Your average has to lie between the two masses. The reason I'm saying that is if you start typing numbers into your calculator and you end up with a number that is not between 79 and 81, you've done something wrong. So you should go back and fix it. So we're going to plug in our numbers. So we've got 79 goes with 55. And then that is being added to 81 times 45. And then that whole thing is being divided by 100. So when you plug that into your calculator, which you'll be allowed to use, you end up with a relative atomic mass of 79.9. Okay, so having watched this video, you should hopefully be more confident in describing how the periodic table is arranged, naming and giving properties of the subatomic particles, nuclear notation questions, and also talking about isotopes. Thank you for watching. Goodbye.